Hello, student. It's me again. Now we will look at how nucleophilic addition reaction will lead to the formation of racemic mixture. Okay. Now think of an example. Do you know what kind of products will be produced? Okay. Now, if you remember this H will go to this O. Now I'm not using the arrow because I'm not showing the electron movement. I'm just telling you where the atoms go at the end, and this CM will go to here, right? So you will get the product eventually. The H will be here, the CM will be here. Now, since this is a there is only one product, so it's an addition reaction. Can you see that? And there is a chiral carbon because it's bonded to 4 different groups of atoms. Okay. Now, even though I said that SN1 and nucleophilic addition reaction can produce racemic mixture, but it's not always the case. You have to look at if the final product contains a chiral carbon. For example, this is a butanone, right? If I change it to propanone, then the product will not contain chiral carbon, and of course, there will be no racemic mixture. Okay. Now, the next step, we will look into the nucleophilic addition to see how it can lead to the formation of racemic mixture. Now, if you remember in the previous video, I said the SM1 can lead to the formation of racemic mixture because the SM1 involves the planar carbocation ion, so that the nucleophile can attack the positive carbon of the carbocation from either side with equal chance, producing a pair of enantiomers with equal amount. Do you understand? So that's why one of them will rotate the plane of polarized light, let's say 30-degree clockwise, and the other one is doing the same anti-clockwise, so they cancel out. Eventually, the whole mixture will not rotate the plane of polarized light. Now, for nucleophilic addition reaction, the explanation is more or less the same, except of course we know that it doesn't involve carbocation. Then which one is the planar molecule that lead to the formation of the racemic mixture? The planar molecule is the reactant. This one, can you see that? If you apply VSEPR theory, this carbon, okay, it has three groups of atoms, okay? Its bond pair is 3, but its lone pair is 0. So if you remember the VSEPR theory, this is planar. So basically, its shape is like that. Okay? It's planar, which means it can be put on a piece of paper, okay? Do you understand what I'm saying? If you remember the first step of the nucleophilic addition reaction, it will be the attack of the nucleophile to this positive carbon. Likewise, comparing with SM1, this one can attack from the front or from the back. Okay, so this will lead to a pair of enantiomers with equal amount because the chance for this to happen is 50-50, same as SM1, except SM1 it happens in the intermediate stage. Okay, the planar carbocation is attacked by the nucleophile from either side, but this one is at the beginning of the stage, okay, because the reactants originally the carbonyl compound is planar. Okay, so if you remember, what will be happening is once this attacks the positive carbon, this bond is broken, then you will get this one. Let us do some revision on this. On this mechanism. Okay, and then the next step will be this negative O. will attack this edge and this bond will be broken. So you will get the product. And the Cn minus will be regenerated. Do you understand what I'm saying? Okay, I repeat once again, there are several main points in these three videos. The first one is you have to understand the definition of racemic mixture. Racemic mixture is a mixture that contains equal amount of a pair of enantiomers, okay? Enantiomer A and B, and their mirror image of each other, equal amount. And there are two mechanisms in your syllabus that can lead to the production of racemic mixture, okay? It's not necessarily always true. You have to look at if the product has a chiral carbon, but if the product has a chiral carbon, then racemic mixture will occur. If the process of the reaction involves either SM1 or nucleophilic addition, because for SM1, it involves the planar carbocation as the intermediate, and the nucleophile can attack on either from the front or from the back, producing equal amount of a pair of enantiomers, because the attack from the front and from the back is of equal chance to happen. And for this nucleophilic addition, okay, and this attack from the front and from the back is also happening because the original reactant, this carbonyl compound, according to VSEPR theory, this central atom has 3 bond pair, 0 lone pair. So it is planar, okay? Planar means you can put it on a piece of paper with the bond angle 120 degree, okay? So this nucleophile can attack the positive carbon from either the front or the back, and with equal chance, producing a pair of enantiomers with equal amount. This is racemic mixture, okay? It will lead to the racemic mixture. Okay, remember, now, after watching these 3 videos, if you remember, there is a worksheet I gave you that is the organic question, organic chemistry question. At the end of this part, it will involve a small part asking you about this racemic mixture. And I will resend these worksheets to you, and I really hope that you can spend time on watching these 3 videos and try the worksheet. In the next video, I will explain the questions on that worksheet, okay? Keep going, working hard, okay? We will have Zoom lesson next week, practical for 2 days. And if you have any questions, feel free to contact me anytime. Or if you need individual help, you can schedule, you can talk to me, and then we can work out a time slot to schedule an individual Zoom lesson for you. Remember, I'm always here to back you up. Do not give up, students, okay? See you.